Welcome to the DIY Honda Garage channel. The DTC P2A01 indicates a circuit range or performance problem related to the secondary heated oxygen sensor, specifically known as Sensor 2 in the Honda CR-V 2023 and newer models. This code is triggered when the output voltage from the secondary heated oxygen sensor is lower than an acceptable threshold determined by the Engine Control Unit, or PCM. The secondary heated oxygen sensor plays a crucial role in monitoring the exhaust gases and ensuring the engine is operating efficiently by adjusting the air-fuel mixture accordingly. Typically, you can find this sensor located in the vehicle's exhaust system downstream of the catalytic converter. If it detects that the emissions are not within the expected parameters, it sends a signal to the PCM, which then stores this code for diagnostic purposes. Understanding this DTC is essential for accurate diagnosis and repair to maintain engine performance and compliance with emissions regulations. The DTC P2A01 indicates that the output voltage of the secondary heated oxygen sensor, Sensor 2, is falling below specified thresholds, prompting the powertrain control module, known as PCM, to identify and store this error code. The secondary heated oxygen sensor is vital for monitoring the level of oxygen in the exhaust gases after they have passed through the catalytic converter. It acts as a feedback mechanism to optimize fuel efficiency and reduce emissions. If this sensor is not functioning properly, it can lead to inefficient engine operation, where the air-fuel mixture may not be within optimal levels, resulting in either excessive fuel consumption or higher emissions. The location of the secondary HO2S is generally downstream in the exhaust system beyond the catalytic converter, where it can effectively measure the efficiency of the converter's operation. Diagnosing DTC P2A01 involves several potential causes, each needing thorough inspection. One common cause is a faulty secondary heated oxygen sensor itself, which may not be producing the correct voltage output necessary for the PCM to determine the oxygen levels in the exhaust. Another common issue could be related to open circuit problems, where wiring or connections have been compromised, leading to disconnects or breaks in the signal path. Additionally, a malfunctioning PCM can also trigger this code, indicating that it might not be processing sensor inputs correctly. Each of these possibilities warrants careful examination to restore the proper functioning of the vehicle's emission system. An accurate diagnosis is essential to resolve the underlying issues effectively. The DTC P2A01 may present several noticeable symptoms that can aid in diagnosing the issue. First and foremost, drivers might experience decreased fuel efficiency, as the vehicle could be running richer than necessary due to incorrect readings from the secondary HO2S. Additionally, increased emissions are another critical symptom. If the sensor is faulty, it may fail to properly monitor and adjust the air-fuel mixture, causing the vehicle to produce higher levels of harmful emissions. The check engine light illuminating on the dashboard is often the first indication a driver receives about potential issues with the vehicle's systems, alerting them that the PCM has detected a problem that needs attention. Addressing these symptoms is imperative, not only for vehicle performance, but also for compliance with environmental regulations. The first step in troubleshooting DTC P2A01 involves starting the engine and holding the engine speed at 3,000 RPM without any load. This means the vehicle should be in either park or neutral while observing this procedure. Maintaining the specified engine speed is essential because it ensures that the vehicle reaches operational temperatures and conditions that the secondary heated oxygen sensor needs to function effectively. Once this state is achieved, it's necessary to monitor the Honda Diagnostic System, or HDS, specifically looking for the DTC P2A01 to confirm if it is active during this test. This real-time assessment allows us to evaluate whether the initial conditions that triggered the DTC still exist, or if further diagnostic steps are necessary. Collecting this data is crucial for understanding the sensor's current performance under controlled conditions. The second troubleshooting step focuses on performing detailed circuit inspections, specifically for the secondary heated oxygen sensor and the related PCM wiring. Initially, it's essential to disconnect the secondary HO2S connector and the PCM connector to facilitate a thorough inspection. You'll begin by checking for an open circuit in the SO2 circuit, where confirming continuity should indicate less than 1 ohm of resistance. Next, you'll inspect for continuity in the ground circuit, SO2SG, SO2SG, also expecting a similar resistance reading. This step is pivotal as it helps identify any wiring issues that could cause the sensor to underperform. If any irregularities are found during these inspections, corrective actions can be taken before proceeding to further diagnostics or component replacements, ensuring the integrity of the circuit connections is restored. During the third step, you delve into checking for short circuits in both the SO2 circuit and the ground circuit. After confirming that there are no open circuits, it is critical to examine whether the circuits have been compromised due to shorts to ground. As before, using an ohm meter will help in determining if there is more than 1 mega-ohm resistance, indicating that no shorts are present. Following this initial inspection, the next logical step is to test the secondary HO2S with known good components. Replacing the faulty sensor temporarily with one that is confirmed to be operational can often help demonstrate whether the DTC reappears or resolves. If the code persists, further diagnostic testing may be necessary to explore other components, primarily focusing on the PCM to ensure it correctly interprets the signals it receives. In the final repair verification stage for DTC P2A01, it is crucial to confirm the success of the repair efforts. This involves first checking that the DTC has been cleared from the PCM after the corrective measures are taken. The PCM, or Powertrain Control Module, should show no active or pending DTCs once the repairs have been made. After clearing the DTC, a test drive of the vehicle is essential to ensure that it operates under various conditions, allowing time for the vehicle to reach its normal operating temperature and pressure stability. This process helps assess whether any previously noted symptoms reoccur during normal driving. If all symptoms have been resolved and no DTCs return, the repair can be considered successful, ensuring that the vehicle now meets the required emission standards and operates efficiently. To prevent future occurrences of DTC P2A01, several proactive maintenance strategies can be implemented. First, regularly checking the condition of the secondary heated oxygen sensors can provide insights into their functionality before issues become critical. Keeping wiring clean and secured is essential, as frayed wires or poor connections can lead to error codes. Additionally, monitoring the overall health of the exhaust system can help spot potential issues before they affect the performance of the oxygen sensors. Scheduling routine inspections can not only enhance reliability, but also extend the lifespan of the engine components and ensure compliance with emissions regulations. Such preventive measures ultimately deliver cost benefits in terms of reducing repair expenses and maintaining optimal vehicle operation. In conclusion, DTC P2A01 serves as an important indicator of issues related to the secondary heated oxygen sensor. Understanding the functionality of this sensor and its relationship with the PCM helps in the efficient diagnosis and resolution of the problem. During the troubleshooting process, meticulous attention must be given to circuit integrity and sensor performance. Following a structured diagnostic approach ensures that the root cause is accurately identified and addressed. Furthermore, implementing preventive maintenance practices can reduce the frequency of such error codes in the future and optimize vehicle performance. By adhering to these best practices, vehicle owners can enjoy a more reliable and emissions-compliant driving experience. Please like and subscribe to the channel. See you next time.